Okay, so I don't know how to factor something with a to the fourth in it, but I would know how to factor if it was something squared. So I need to rewrite this a to the fourth as something squared. I know a to the fourth is a squared times a squared, so I could rewrite this as a squared times itself, or in other words, a squared squared. So a squared squared minus 5a squared minus 14. So you could say this is in the format of something squared minus or a number times that thing minus a number, and then you could factor from there. If you find the a squareds being here a little bit confusing, one thing you can do is replace them with a different variable. So pick a different variable, anyone will do, and say say I pick k, let k equal a squared. This is just the syntax for when you want to replace something with a different variable. Now wherever you see a squared, replace it with a k. So I get k squared minus 5k minus 14. Okay, this looks much more familiar. It's something that we can easily factor. So there's no coefficient in front of the k squared, it's just 1. So if this is factorable, it was split into two brackets. K is the first thing in each one. And I'm looking for two numbers that multiply to get negative 14, add to get negative 5. So I'm looking for a negative and a positive number, and the negative one has to be bigger. So negative 7 and a positive 2 should work. Then after that, you're going to have to, because your question was in the format of a something, you have to phrase your answer in terms of a as well. So wherever you see a k, sub back in the a squared. So you'll get a squared minus 7 and a squared plus 2. Then you want to do one last check to see whether any of these brackets are factorable. So the a squared plus 2, I know right away that's the wrong format to be factorable. A squared minus 7, since 7's not a perfect square, I can't do a difference of squares here, so this one isn't factorable either. So you've gone as far as you can go. This question's done. If you had seen right away the pattern here and you wanted to skip directly from here to here, that's fine too. This substituting a different variable is an optional step. Alright, part B. So again, I need to write this x to the fourth as something squared. So I'll write it as x squared squared plus 4x squared minus 5. So I see the pattern of something squared here. And since this first term has a coefficient of 1, I'm going to try factoring it directly. I know that x squared will be the first thing in each bracket. And for my number terms, I'm looking for a number that multiplies to get negative 5 and adds to get positive 4. So I need a negative and a positive number. The positive one has to be bigger. So positive 5 and negative 1 should work. Now you're going to look inside each bracket to see whether it can be factored further. So the x squared plus 5, I can't do a thing with that. So leave that as it is. The x squared minus 1, this is the same as x squared minus 1 squared, so that's a difference of squares. And I can factor this as x minus 1 times x plus 1. Look at your brackets again. Nothing else can be factored, so that's your final answer. If you had started from this step and substituted a variable, that would be fine too. I can say let q equal x squared, and then when you sub it in, you would get q squared plus 4q minus 5, which equals q plus 5 times q minus 1. Then you would have to sub back in your variables. So x squared plus 5 times x squared minus 1. And then recognize that that x squared minus 1 is a difference of squares and can be factored further. So x squared plus 5 times x minus 1 times x plus 1. You would get the same answer. So it's up to you whether you want to use this method or not. Okay, last question. Now I need to write the x to the sixth as something squared. So x to the 6th I could write as x cubed times x cubed, or in other words, x cubed squared minus 9x cubed plus 14. I recognize the pattern here, and my first term's coefficient is just 1, so I'm going to try factoring it directly. I know that x cubed will be the first thing in each bracket. And I'm looking for two numbers that multiply to get positive 14 and add to get negative 9. So I know they both need to be negative numbers. Negative 7 and negative 2 should do it. Finally, you're going to check to see whether either of these brackets are factorable, and they're not. So that will be your final answer. Or if you'd switch to a different variable at this point, I could say let p equal x cubed, and then your equation would become p squared minus 9p plus 14, which equals p minus 7 times p minus 2, and then you would have to substitute in your x cubeds, so x cubed minus 7 times x cubed minus 2. Neither one of these are factorable, so that's your final answer.